right, today we're going to look at special right triangles. So you have 45, 45, 90s and 30, 60, 90s that we're going to look at. So the other day we looked at Pythagorean theorem, where if we had a right triangle, we were able to find a missing side using a squared plus b squared equals c squared. And still, that's probably going to be like your go-to method. But when I look at example 3, I see that I have a right triangle, but I only have one side. So we can't plug into a squared plus b squared equals c squared. So we now have to do some problem solving. We have to figure out what the heck's going on. Looking at this triangle right here, I see it's right, but I also notice that I have a 45, 45, 90. So when you have a 45, 45, 90 triangle, they have this special relationship. And this is a formula, I guess you could say, that you'll be given. Okay, it's going to look just like this. So you have your right triangle. I have 45s going on, so 45, 45. Got the 90 already. And then I'm going to go around labeling my sides as S, S, S square roots of 2. Okay, so when I work my way around the triangle, I know that both of my legs are going to have a length of S, and then my hypotenuse, which is the key, is going to be the length of one of the legs multiplied by the square root of 2. So from there, just like we've been doing in this class so far, you got to build the picture. Okay, so I got my right triangle, 45, 45, 90. I'm going to go ahead and label the sides. So my hypotenuse is S square roots of 2. And then both my legs are going to be S. So to find the missing sides, XZ is just going to have a length of S. So it's going to match up with the side they gave us. So XZ has to be 7. And then YZ is going to be the leg length, so S, 7, times square root of 2. That's it. That's all you have to do, okay? So it looks a little weird, I guess, but really the big thing is you have to be able to identify what you're dealing with. You have a right triangle. Can't use Pythagorean, so there's going to be one side, so we have to go to our special triangles. Second triangle on the right, okay? Look at it. Again, right triangle, they only give me one side. It's 45, 45, 90. So I'm going to go ahead and start labeling sides. Hypotenuse is S square roots of 2. Both my legs are S. Okay, so if I want to find KL, which I do, it's just S. So there's two ways you can do this. You can just look at it and say, all right, if I get rid of the square root of 2, I'm just left with 12. Or probably what you want to get in the habit of doing is taking that hypotenuse and then dividing it by the square root of 2. Okay, because if I have S square roots of 2 and I divide by the square root of 2, they're gone and it just leaves me with S. Either way, in this case, you're going to get 12 for length of KL. Okay, since I already found what KL is, that's the length of S, I'm pretty much set. Just got to go ahead and say, okay, KJ is going to be the same. It's SS, it's going to be 12. Okay, so that is for a 45, 45, 90. And like I said, up here, this triangle that we have, you will be given on any quiz or test you take. So you become familiar with it and be able to use it. The other type we're going to look at is a 30, 60, 90. Okay, so again, you look at them, you got right triangles going on. Okay, so first thought needs to be Pythagorean theorem. But since they only gave us one side, you can't use the Pythagorean theorem. So you're going to have another formula, you could say. So this one, I got a 90. We got 30, 60. And this one's a little more complicated. When we work our way around, 2x is going to be the hypotenuse. The leg across from 30. Okay, so my small side, the one across from 30 is x. And then the one across from 60 is x square roots of 3. Okay, this one you have to pay attention when you label. Okay, it's real important, like which side gets the x and the x square roots of 3. Okay, so looking at A, 30, 60, 90, can't use Pythagorean. I'm going to start labeling, okay? So across from the 30 is my x. Across from the 60 is x square roots of 3. And then across from my right, so my hypotenuse is going to be 2x. All right, on this one, they went ahead and gave us x, which is like easy, okay? It's a piece of cake. PQ is just my x times square root of 3, so we got 6 square roots of 3. My PR, so the hypotenuse, is just twice x, so 2 times 6, 12. Okay, so that's easy enough. B, they switch it up a little bit. Okay, so on B, 30, 60, 90 again, let's go ahead and label sides. So across from the 30 is my x, across from the 60 is x square roots of 3, and across from the 90, so my hypotenuse is 2x. All right, the key to these problems is you always want to work your way down to x first, okay? Always work your way down to the small side first. So that would be UV. Okay. If x square roots of 3, so I'm going to do it over here, x square roots of 3 equals 9 square roots of 3, then x has to be 9. Okay, so I get 9 for UV. Once you have x, it opens everything else up. To get TV, you're just doubling it. So 2 times 9, 18. Okay, so once again, you'll be given that formula just like we were in the other one. You'll be able to identify the triangle and work your way through. So there's one other one I want to look at. It's going to be example 5. The try it on example 5. So try it on example 5, like mixes it all together. Okay, you look at A, you look at B, they're right triangles. We only have one side, so you can't use Pythagorean there. Okay, so 30, 60, 90, working our way through this. You go back to your formulas that I gave you on the previous page. Across from the 30 is x. Across from the 60 is going to be x square roots of 3. The hypotenuse is 2x. Okay, the key to the problem is finding x. You have to figure out what x is. So I know x square roots of 3 equals 28. Okay, from here, we need to go ahead and solve for x. So x is going to equal 28 over the square root of 3. Now, this is where we have a little bit of an issue. Okay, you cannot leave a square root in the denominator. So what you have to do here is actually multiply the denominator and the numerator by whatever the square root is. So in this case, square root of 3. When you do square root of 3 times square root of 3, it's just going to leave me with the number 3. Okay, the square roots go away. I'm just left with 3. Numerator is just going to be 28 square root of 3. And that would be your answer right there. Okay, so BC equals 28 square roots of 3 over 3. As soon as you have that, it's really easy to find AB. To find AB, it's just twice this. So you go ahead and do 2 times 28, and it's going to give me 56 square roots of 3 over 3. Okay, but the key to that problem is you cannot have a square root in the denominator. So when you have that square root in the denominator, make sure you multiply denominator, numerator by whatever that square root is. B, a little easier. You got 45, 45, 90. So for 45, 45, 90, your hypotenuse is s squared to 2. And then your legs are both s. Okay. On this one, we have s square roots of 2 equals 14. We need to find s. You divide each side by square root of 2. So s equals 14 over the square root of 2. Just like we had in the last one, it was squared in the denominator. So I have to multiply denominator, numerator by square root of 2. So up top, I get 14 square roots of 2. Denominator, so whenever we multiply a square root by the same thing, just goes away and we're left with the number. Okay, so I'm left with 14 square roots of 2 over 2. And then we can totally do 14 divided by 2. 14 divided by 2 is 7. So for this triangle, AC is going to equal 7 square roots of 2. and BC is going to equal 7 square roots of 2.